सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स, डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी हर बार की तरह आपका हार्दिक अभिनंदन करता हूं जस्ट केमिस्ट्री वाला चैनल में। रिगार्डिंग टू योर केमिस्ट्री, हम पर्टिकुलर बात कर रहे हैं ऑर्गेनिक केमिस्ट्री में हेलो एल्केन हेलोरिन की। हेलो एल्केन हेलो एरिन में हमने बहुत सारे टॉपिक डिस्कस कर लिए हैं। अभी जो चल रहा है पर्टिकुलर स्टीरियो एस्पेक्ट्स की बात चल रही है, जिसमें हमने 5 इंपॉर्टेंट एस्पेक्ट्स की बात की है। इंपॉर्टेंट इज योर जस्ट फर्स्ट simple light, second your Nicol prism, third is your plain polarized light, fourth is your just important topic, what is that optical activity, five is just polarimetry. Now I would like to go with the next topic, that is specific. It is known as specific rotation. Specific rotation. First, we'll go with the meaning of specification. If we'll go with the just representation, then it can be represented by the alpha. This is the T degrees Celsius. This is your lambda, denoted by just alpha T degrees Celsius lambda. You can say specification is the rotation of just plain polarized light, plain polarized light by the solution in 1 gram per ml as concentration. This is the most important. 1 1 dm means decimeter. Length of sample tube is called as just specification. We have discussed just specific rotation is your alpha. This is the T degree Celsius as a temperature. This is the lambda is equals to, this is your alpha observed upon L into C. This is the formula of specific rotation. Specific rotation. The value of specific rotation will be defined for each and every compound. And suppose if there is, as example, is alpha, this is the 20, and here we can take, this is the most important thing, just as lambda also, you can say d also. Then here is specific rotation, and 20 is the temperature of temperature in degree Celsius, and d shows about the wavelength of light, and that is fixed for the, just because we are using here monochromatic light by the in the form of sodium lamp, so its value will be 5893 angstrom is the fixed value. If we'll go with the specific rotation, then it is specific rotation is one of the property of compound similar to boiling and melting point. ये भी बॉइलिंग और मेल्टिंग पॉइंट की तरह स्पेसिफिक प्रॉपर्टी होती है जो कि उसके स्पेसिफिक कैरेक्टर को शो करती है. This was about the specific rotation. Now I would like to go with the next topic, that is your molar rotation. It's a very important. This is the molar rotation. It is denoted by small m. Just you can say product of you can say specific rotation and molar mass and molar mass of compound is called as just molar rotation. So this is the molar rotation is denoted by small m. This is the specific rotation into molar mass of the substance which has taken in the sample tube. Molar mass of substance. If we'll go with the formula, then we can say m is equals to, this is the alpha, this is the T degrees Celsius as a temperature, this is the lambda, you can denote it by D also, and it is the product, that's why here will be capital M as a molar mass. So this is the molar rotation as an important point. Here alpha observed, which is just taken by the just polarimeter, and this was about the molar rotation. Now I would like to go with the important word, that is the chirality. It's a very important word, chirality. If I'll go with the just discovery, then it was discovered by Lord Kelvin. This is the discovery by Lord Kelvin. This is the Lord Kelvin. According to him, if I'll go with the chirality word, then chirality word is developed by a Latin word, just your Kia, where Kia means where, where Kia means Kia means just like our hands, हमारे हाथों की तरह. कैसे कि अगर पर्टिकुलर मैं अपने इस लेफ्ट हैंड को मिरर में देखता हूं तो राइट हैंड की तरह दिखेगा, राइट हैंड को मिरर में देखूंगा तो लेफ्ट हैंड की तरफ दिखेगा. तो उस पोजीशन में दोनों एक दूसरे के सुपर जस्ट मिरर इमेज, बट ये सुपर इम्पोज नहीं है, क्योंकि सुपर इम्पोज के लिए जरूरी है एक का वेंट्रल साइड दूसरे का डोर्सल साइड इस टाइप से होना चाहिए था, फिर अंगूठे के नीचे अंगूठा आता, नीचे उंगली आती, तो ये सुपर इम्पोज था, otherwise it's not imposition. So what we'll say, we will say just our hands, yeah, you can say our hands are mirror image of one another, but they are not superimposable. Such property is called as chirality. Just the compound, that compound called as chiral compound or chiral molecule, chiral compound or chiral molecule. If we go to the just cause of chirality, then asymmetrical condition of center carbon causes chirality. मीन्स पर्टिकुलर chirality का बेसिक कॉज क्या है, जस्ट मॉलिक्यूल में एसिमेट्रिकल कंडीशंस हो, किस टाइप से, सी द मैटर प्रॉपर्ली. So chirality can be explained over here, and just you can say we'll take deeply also. I'll explain the matter. This is the regarding to chirality. After that point, we can say chirality arises. Chirality arises due to just absence of symmetric elements, such as you can say center of symmetry, you can say axis of symmetry, and you can say this is the plane of symmetry. Plane of symmetry मीन्स पर्टिकुलर ये सब कंपोनेंट एब्सेंट होंगे, किसी भी टाइप की कोई भी सिमेट्रिक नहीं होगी, then that will be optically active, means that will be as a chiral molecule. Let's see, this is the condition for the chiral molecule. This is the carbon, here's the A, B, C, and this is the D group. If we can say A is not equals to, if A is not equals to B, is not equals to C, is not equals to D, then this carbon is called as chiral carbon. This is the star as a chiral carbon. This is the chiral carbon. If I go with the just example, then we can take the some of the example as a first butane 2-ol, just regarding to haloalkane 2-chlorobutane. If I go with the just butane 2-ol, then the structures are as follows. This is the CH3 COH, this is the HCS2 and CS3. This is the chiral carbon, and 2-chlorobutane CH3, this is the CHCl, this is the CS2 and CS3, this is the chiral carbon. Now we will say these are the molecule having one chiral atom. So these are the molecules having one chiral carbon. If you will go with the just another practice, we can take over here, that is the very important. This is called as tartaric acid, which exists in tamarind. Its structure is as follows: COOH, this is the CHOH, this is the CHOH, and this is the COOH. If we'll go with the just structure, then it can be shown as follows. This is the COOH because it's a condensed formula, COH and H. This is the COH and H, and this is the COOH. Here are just two of the chiral center, one of the carbon this one, another this one. So we'll say this is the molecule having two chiral carbon. So this was about the just your important topics, as a we have discussed specific rotation, molar rotation, that is the seventh topic, and the chirality proposed by Lord Kelvin. So dear student, we'll meet in the next video just with the new topic. मैं हर एक टॉपिक को छोटे छोटे वीडियो में इसलिए ले रहा हूँ ताकि आपको पढ़ने में बोरिंग फीलिंग ना हो, हर एक चीज प्रॉपर वे में अच्छे से एक्सप्लेन हो जाए। इसी विश्वास के साथ में इस चैनल को मैक्सिमम सब्सक्राइब करते रहिए, शेयर करते रहिए, ताकि उन बच्चों तक भी पहुंच पाए जो हमारी पहुंच से दूर है, क्योंकि ये कारवां अब नहीं रुकने वाला है, क्योंकि वीडियो अपलोडिंग कंटिन्यू होती रहेगी। तब तक के लिए धन्यवाद, शुक्रिया।